Well, good afternoon. I'm really pleased to see so many people here, especially because there may or may not be a storm today.
No, there will be.
Today?
Yeah.
We'll
Yep.
see. Okay, and welcome to NEST. For those of you who don't know, this is a network for economic and social trends, and we're really pleased to be having this presentation today. Before we get started with today's presentation, I would like to acknowledge that Western University is located on the traditional lands of the Anishinaabeg, Haudenosaunee, Nanaipawak, and Chinooktun nations on lands connected with the London Township and the Sombra Treaties of 1796 and the Dish with One Spoon Covenant Wampum. Further, we respect and affirm the inherent and treaty rights of all Indigenous people across this land. We have and we will continue to honor the commitments to self-determination and sovereignty we have made to Indigenous nations and peoples. We acknowledge the historical oppression of lands, cultures, and the original peoples in what we now know as Canada, and we fervently believe that we should contribute to the healing and the decolonizing journey we all share together. And now I'm going to call on Isaac to introduce our guest.
If you want this seat, I'm going to be standing up.
I've already got my tea. Thank you.
Thank you, Vicky. So I'm Dr. Kristie. We are very happy to have you come to Western, and we know that it's a challenging arrangement given the current weather situation across US and Canada. Yeah. So we are very happy to have you here. And Dr. Ivy is a professor in the Center of Health and Global Environment in the School of Public Health at the University of Washington. Seattle, not Washington, D.C. I'm sure most of us, when we hear Washington, we think about the big Washington, the other one. Yeah. She has been conducting research on health risk of climate variability and climate change for more than 55 years. Her research focuses on understanding the sources of vulnerability, estimating current and future health risks of climate change, designing adaptation policies and measures to reduce risk of climate change, using multi-stresses environment, and quantifying health and co-benefits of mitigation strategies. A leading work on assessing human health vulnerability and public health intervention in relation to climate change adaptation has heavily informed the way research on climate and health is conceptualized globally. If you are curious, go and check it out. Okay. She has worked with multiple countries in Africa, Central Asia, Central America, Europe, and in the Pacific in assessing vulnerability and implementing adaptation measures. She was a lead author of the Intergovernmental Panel on Climate Change, IPCC, we all call it now, Safe Assessment Cycle Report, including the specific report on the warming of the globe at 1.5 degrees and the Human Health Chapter for Working Group 2. She was lead author for the 4th U.S. National Climate Assessment Report. She also co-authored several books, and there was a co-author of the International Committee on the New Integrated Climate Change Assessment Scenarios. She has published more than 200 peer-reviewed papers and ably sought after. I remember working with Dr. Ivy somewhere in Belgium, in Brussels, and she would go out and take a phone call and come back, and I'm like, oh, what a life. There she is, and she is going to tell us about climate change effects and health. You're very welcome.
Thank you very much for the kind invitation. I'm really pleased to be here. I'm really sorry that Gordon can't. It's really unfortunate that he, unfortunately, if you don't know, has COVID and will watch this remotely whenever he's supposed to. But really appreciate the invitation. I want to start with framing points that are important when we think about what the consequences are for human and natural systems. And this is the figure on the left. It's from the IPCC. It's been the framing used for more than a decade. When we look at the future, we're looking at risk. Risk is probability times consequence. Risk doesn't have to be realized, but we want want to understand the risks so we can understand what kinds of actions can be taken to intervene on those risks so that they don't turn into observed impacts. The IPCC likes to divide risk into three main factors. I'll use four because I think that's somewhat more helpful, but they use three. The first are the hazards created by a changing climate. The second are the human and natural systems exposed to those hazards. And it's important to disentangle these various factors because it really makes a difference for thinking about intervention. And then the third is the underlying vulnerability of the exposed human and natural systems. I think personally that it would be helpful to disaggregate vulnerability into susceptibility, so the real susceptibility to be harmed by exposure to a hazard, and the capacity to manage that. For ecosystems, of course, ecosystems themselves can't manage that, but humans are intervening in ecosystems, and so it's really important to understand that capacity. When you use that then for health, the figure on the right is one of many, many, many figures that are like this. Shows you some of the changes that are going on, and I'll talk about how some of those can affect health. And then in this IPCC framing talks about how the exposure to these hazards intersects and interacts with a broad range of demographic, socioeconomic, and environmental factors. And there's just a short list of those there. These interactions then affect exposure pathways that we traditionally study in environmental health. And that's the extreme weather events on the left to social factors on the right. Underneath is just a few examples of climate-sensitive health outcomes. There's literally hundreds of them. And so that is a very short list. It shows you that the field has a lot to cover. So far, we've only been able to cover a tiny fraction of that. It's not because of lack of interest, it's because of lack of funding. So I'll mention several times throughout this a major theme in this field is it just hasn't been a field that there's been much investment in. When you look in the United States, for example, the National Institutes of Health, for the last decade or so, their investment in climate change and health is less than 0.02% of their budget. And it's not been that much different in Europe or in Australia. It's shifting here in Canada. When Prime Minister Trudeau was elected, there's been investments in Health Canada. And so one of our challenges is we understand the breadth and depth of what we're dealing with in general terms from first principles, but we often don't have the details we'd like to have. So for those of you who are students, a great place to start going into because there's so many questions that need to be answered. All the health risks of a changing climate are current problems somewhere. It's not like in some of the other impact sectors where new issues are going to arise. Certainly we might see new issues. But almost all the issues are going to be expansion of geographic range, of a variety of infectious diseases, intensity of impacts from extreme weather climate events. And so we already have a good sense. And because these are issues that have been assessed, evaluated, monitored to some extent, there's a lot we can build on in terms of adaptation. We understand the exposure, we understand the resilience. This is a figure from the 4th National Climate Assessment, just giving some examples of communities that are more highly exposed to flooding, for example, and the kinds of actions that can be taken to help protect those communities. So we're building on a really solid base. One of the other ways we differ from the other sectors is because we already have policies and measures to address, for example, flooding risk. We can build on those, but none of our policies and measures were designed with climate change in mind. All of them made the implicit assumption that the climate was static. And so there's a lot of work to do in basic education. That yes, the climate is changing, it's going to continue to change, and if we don't make some interventions a priority, then we're going to see higher risks of a whole range of climate-sensitive health outcomes. I know you're never supposed to use a slide with this many words, but well, we all know that. We've all got these, don't It's a very brief summary of the human health chapter in the IPCC. And it's just really, frankly, the best way to do that. You can see the headline statement that climate change is adversely affecting the physical health of people globally and the mental health of people where we have data. I'm going to talk about some of these. I want these up here just so that you see there's a pretty long list of categories. The bottom bullet is important. I'm not going to talk about it, but it's about our health care facilities and how many facilities are in harm's way. And that's a whole lecture, a field of study in and of itself. And I won't do that, but I will acknowledge how very important it is. There's been very nice work done through Health Canada, looking at healthcare facilities and how they're being affected. I remember a heat wave, I think it was in Saskatchewan, but I don't remember exactly, several years ago where the emergency departments had to shut down, the operating rooms had to shut down because it was too hot for the operating rooms to safely run. They couldn't condition the air enough for them to be safe. And so that is an area where a lot of work needs to be done. And so starting to run through a few of the issues, for those of you working in climate change, I'm sure you have seen this. Every year NOAA puts together this list of billion-dollar disasters in the U.S. I always find it interesting because I look at these figures and I think, I don't remember half of these, if at all, which is kind of sad that I can't seem to remember these. The second point I make frequently to my students is there was 22 disasters in the U.S. last year, billion-dollar disasters, that together cost the U.S. economy over $120 billion. So when you hear people say it's too expensive to address climate change, it's too expensive not to. The other critically important issue is these are insured losses. I'm going to talk in a few minutes about the Pacific heat dome. That was not a billion-dollar disaster. People died, but it wasn't an insured loss. And so if this included all of the impacts on health, on well-being, on mental health, you get a very different sense of how our populations are being affected. One issue that's been rising quite rapidly on our agenda is mental health. These are really good data from the UK from flooding almost a decade ago. I said it's good data. The reasons are the way they analyze their data. And you can see there's 3 years of follow-up for people with anxiety, post-traumatic stress disorder. And very usefully, the authors separated out the population into 3 groups. People who lived in a residence that was not affected. People who lived in a residence that was disrupted. Floodwaters came to the front door, they didn't go inside. And people lived in a residence that was actually flooded. Most of the health research conflates the disrupted and the actual flooded, which doesn't help because you're putting together 2 different sets of experiences. For each one of these, the bar on the left is the first year, the year with the flood. The second and the third year follow-up. And you can see for both of these, anxiety and post-traumatic stress disorder, as you would expect, significant increases in year 1. And for the disrupted and the flooded in years 2 and 3, the prevalence of these disorders don't go back to baseline. There's no health system anywhere in the world that's ready to manage the mental health outcomes of extreme weather and climate events. There's lots of talk about what can be done with our health systems to be better prepared. And these are high-income countries. Several of you are from low and middle-income countries where you probably have almost no mental health counseling whatsoever. And these events cause, as you can see, very high levels of anxiety and PTSD. And even in high-income countries, there's just the assumption that somebody goes through an experience like this and they've recovered somehow within a few months, even though they haven't been able to move back into their housing, they least 2/3 of the research in climate change and health is on heat. So I'll talk a lot about heat because that's where most of the research has been. Essentially, every heat-related death is preventable. Nobody needs to die from the heat. You can't prevent all deaths when there's massive flooding. People die in floodwaters, but people don't have to die from the heat. What we care about is the core body temperature. So we have, all of us have a pretty narrow range of our core body temperature. And that's to protect our cells and our organs. When it starts getting to be hot, we all have behavioral mechanisms and physiological mechanisms to reduce our core body temperature. It's really hot, you go find someplace in the shade. If you have access to a body of water, you go by the body of water. You try and find someplace to cool down. If that is insufficient, then our physiological mechanisms kick in. So we experience heat stress. We experience heat strain. Eventually we'll start sweating. So there's all kinds of mechanisms our bodies have to protect us. If together those are insufficient for very high temperatures, our core body temperature starts to rise. And that's what these cycles show you of the kinds of consequences as our cells get too hot. When you look after a heat wave and look at the number of excess deaths, so not counting how many people have a death certificate that they died from the heat, but how many deaths you would have expected during that period in a normal year and what you actually observed. About half of all excess deaths are from cardiovascular disease. These are people who have a heart attack and died from a heart attack who wouldn't have had a heart attack otherwise. So these are truly preventable deaths. And the numbers can be very, very large, and they don't have to be. There's a lot of work ongoing to improve early warning systems to make sure that they're much more responsive to our changing climate. Worldwide, the exposure of vulnerable populations to heat waves has increased dramatically. These are data from the Lancet Countdown. Adults over the age of 65, children under the age of 1 from 1980 to 2020. You can see the numbers up there. For adults over the age of 65, who are traditionally considered to be most vulnerable, you see there's been more than 3.1 billion additional heat wave exposure days over the long-term average. And for those of you working in climate change, you know these numbers are just going to continue to increase with increases in the frequency, intensity, and duration of heat waves. This health sector is finally starting to use detection and attribution methods. How many are familiar with detection and attribution? Small number. Detection and attribution is a formal statistical method that does exactly what its name implies. You first detect whether there's been a change in a trend. And if there's been a change in a trend, you then look at why. And you partition out the various drivers of why there's been a change in the trend. Most of this work has been done in the climate science and is showing that heat waves are increasing in frequency, intensity, and duration because of climate change. So the question is, how is that affecting health? This is a modeling study that takes advantage of a modeling study done in the climate science and pairs it with some modeling that's been done in health. Looked at over 700 locations in 43 countries and asked over the last few decades what proportion of heat-related deaths in the summer are because of climate change. Over these 43 countries, it's 37%. You can see the variability as you go around. The amount attributable to climate change varies from place to place. You can see there's only one data point, South Africa, for all of Africa, which is not, of course, representative of all of Africa. But it is a very important first step. This and other studies have changed the rhetoric around climate change and health, because we can now say that people are dying because of climate change. It's not because there's an association between health and weather patterns. We know these weather patterns are shifting, and we know that they are contributing to various health outcomes, and I'll show you more about this later. But it makes a very different kind of communication with policymakers when you say people are already dying from climate change. This is not a theoretical in the future, this is right now. estimate in the U.S. is there's about 12,000 Americans who die from the heat every year. And you say 40% of that, that's a big number. And you start looking around the world, you're talking about tens of thousands of people dying from the heat because of climate change. How many of you followed the Pacific heat dome? Quite a few of you. We followed it pretty closely as well. Apologies, this is in degrees Fahrenheit, but this was published in the New York Times, and the U.S. still uses Fahrenheit. But several points from this. The first is, if you follow your weather patterns, you know that typically a place breaks a temperature record by tenths of degrees. Sometimes it's even hundreds of degrees, but usually they say it's tenths of degrees. This heat dome broke temperature records by 5 degrees Celsius. That just hadn't been seen before. It's just this enormous increase in previous temperature records. Between Oregon, Washington, and British Columbia, over 800 excess deaths. So more than 800 people died in this event that would have died during that period otherwise. And heat is an all of society issue. I have, and I'll continue to focus on the health part of it. This happened at the end of June. It was the height of our cherry picking season, and lost a big fraction of the cherry crop. Oregon and Washington are 2 of the 4 states in the U.S. that have regulations for outdoor workers. And so there was a lot of work done to help protect the outdoor workers. I was struck by a story of one particular orchard. As part of the process of picking the cherries get moved into a cooler, a big, very large walk-in cooler. And they changed their entire process so that every worker spent time in the cooler. They wanted every worker to get that core body temperature back down. And so there was a lot of effort put into protecting the workers. It also happened at a critical time during growing wheat, late June, when some of the flowering was taking place. The high heat then killed off some of the wheat crop. Plant physiologists can explain this better than me, but really affected our wheat. And between just south of Seattle and just north of Vancouver is an area called the Salish Sea. And during low tide, during this heat dome, 1 million mussels, clams, and oysters were literally cooked. It was so hot. And that's food security for coastal tribes. It was an economic hit to the state, but more importantly was the food security issues. So again, this is an all of society issue, and there's lots of efforts now to develop early warning and response systems from the health side, but they have to be in collaboration with other important sectors. I do not know what coastal tribes could have done. Somebody in the tribes could say what could be done. Could they have done more with advance warning? We do know, and I hope that your meteorological services are a little bit better than ours, but up until that point, basically our meteorologists, our broadcast meteorologists would stand up and say, it's hot. Like, yes, we got that. But what do you do about it? And so there's been a real shift in communication around heat and what needs to be done. The other point I'd like to make is how important it is to partner with trusted voices. One of the issues in the United States is sometime in the 1930s, there was a process called redlining. Has anybody heard of redlining? A couple of you have heard of redlining. This was literally where somebody took a city map and drew a red line around parts of the city. And the areas within the red line were areas where black and brown residents could not get a mortgage. It was a way for racism to be perpetuated in the U.S. And as part of the redlining process, those areas had fewer trees planted. So they are hotter today than the surrounding areas. Right? They don't have as many trees, the houses are close together, there's higher population density. The redline districts also are areas where there's typically food deserts, where there's not good quality food available. And so they've got higher prevalence of a range of chronic diseases. So you've got people more vulnerable to the heat in temperatures that are higher. And And so thinking about how you reach out and make sure that people take the action they need to take, you need to work with the trusted voices for the red line districts, because they're the ones who are going to make sure that you get the information to those who are going to take action. So this is just a few of the complexities that we're working on to try and increase resilience to hotter temperatures. And there's a lot that can be done. The default is people go to air conditioning. And you don't have to have air conditioning in most parts of Canada and the US. You might have particular groups who need air conditioning, particularly vulnerable adults over the age of 65 with chronic disease, but most people don't need air conditioning. So these are two infographics from The Lancet, put together from a paper that Ollie J. led, looking on the left at all the different ways people can keep cool without air conditioning. They're inexpensive. They can be implemented anywhere. People have to understand they can do these. On the right, it shows you different settings. In the top row, the top set is individual, but below that is city level. You can plant trees in red line districts. It takes a couple of decades for those trees to grow up and provide shade, but you can get that process started. And so it's thinking about the long-term planning in cities. And part of what's been done around the heat wave early warning and response systems is to have heat action plans. You've got a lot of cranes around here. Seattle is just a city of constant cranes. Buildings are reconfigured all the time. And so thinking about that urban planning and how that urban planning can take into account a much warmer future and make sure, in fact, that cities are going to be more comfortable in higher temperatures. I live in the West, you talk about heat, the next thing you talk about is wildfire. These are also from the Lancet Countdown. The top shows you mean yearly. PM stands for particulate matter. And this is looking at what's called fine particulate matter. Fine particulate matter is exactly the right size that when you inhale it, it goes deep into your lungs, embeds in your lung tissue, and gets absorbed into your body. Anything smaller than fine, sort of the ultra-fine, you breathe it in and breathe it out. It's too small. Anything larger than that gets caught in your bronchial tubes. So the real focus is, and there's thousands and thousands of papers of the health impacts of exposure to fine particulate matter. About 4 million people die every year from exposure to outdoor air pollution, primarily fine particulate matter. Not all of it, of course, from wildfires, but we know there's a lot of health impacts. And so that shows you the exposure. You can see on the western part of the US, there's very high exposure. But interestingly, you can see here and further places east, there's fairly high exposure as well. And that's because the winds blow the particulate matter your way. I live in Seattle. It was fascinating during one of our big wildfires, somewhere between the state of Washington and BC. It's all one landscape. It all kind of comes together. And people on the East Coast were complaining about the smoke that was coming from the West Coast. There wasn't a thought about all of us on the West Coast or what we were breathing, but it turns out that there's more mortality on the East Coast because of higher population density. And so although it's a lower exposure, more people are exposed. The exposures are very high. I don't know if you have it here, but in the US we've got something called Purple Air. Does anybody know if you have Purple Air? Purple Air is an app that shows you, you can pay some small sum of money and they'll put a monitor at your house. So there's hundreds of these things in every city. And I can look at the exposure in my city, in my neighborhood. We measure the quality of the air using the air quality index. Everything over about 60 micrograms per cubic meter is unhealthy for anybody to breathe. In September, there was quite a wildfire just outside of Seattle. My neighborhood was 250. Again, 60 is unhealthy for anybody to breathe. There was communities in Los Angeles from wildfires in Los Angeles last summer where the air quality index was over 700. These are really, really high exposures. And it looks like the particulate matter from wildfire is more toxic than the particulate matter that comes out of tailpipes. So this is a space where you're going to see a lot more information. And then the bottom, as you've already figured out by now, are the trends over time. And we see lots of places in the world where wildfires are increasing. Of course, it's not just the temperature. It has to do with forest management and how we're doing with managing our forests. We often talk about climate change as a stress multiplier. This is one of the places it's a stress multiplier. There's a very nice study done in British Columbia. It came out in 2021. And these are the results for extreme heat exposure, sensitivity, and capacity to manage. And so the authors looked at the communities within British Columbia. They have a 5-point Likert scale and then rank communities in terms of their exposure, sensitivity, and capacity to manage. They did this not just for heat, but they did it for flooding and sea level rise, for wildfire smoke, and for ozone. Ground level ozone is formed on clear, cloudless days. The rate at which it's formed is temperature dependent. And they put it all together. This is really, really helpful for policymakers. This tells you where it's urgent and immediate to start taking action. It's one of the places where we as scientists really need to go. That we continue to be stovepiped between our sectors, even within our sectors. People who work on this issue don't work on that issue. My governor needs to work on all of this all at the same time. My governor needs to know what kinds of actions would be helpful. Needs to have a sense of the magnitude of risk. We had a little talk over lunch about the importance of multidisciplinary approaches. This is it. We have to be able to communicate better the breadth and depth of challenges we're facing with the short, medium, and long term. How many of you have allergies or asthma? It's usually about a third. Yeah, ragweed pollen season. Spring's coming sooner, fall starts later, it's warmer in between. And the ragweed pollen season, you can see a month longer. I'm sure it's even worse than when the slide was put together. I'll talk in a few minutes about carbon dioxide, but it results in more pollen. So not only do we have a longer season, we've got more pollen. Do you have poison ivy here? I grew up in Michigan. Yeah, poison ivy. Yeah, so it grows bigger under higher CO2 concentrations. It's got more toxic oils. Yeah, it's one of those sorry about that. Like yuck. Vector-borne diseases. I'm not going to go through all of this. It's to point out that temperature and precipitation affect the development, survival, and reproduction of a range of what we call vectors. These are mosquitoes and ticks primarily that can carry various diseases. And temperature affects the replication and transmission of the pathogens within the vector. So modeling this is somewhat complicated. I'm not going to go into all of this as an effect of temperature on variables associated with the transmission of dengue fever. The blue line that comes down rapidly is as temperatures go up, the mosquito develops faster. The red line is the mosquito survives better into adulthood. But the green line shows you its activity in terms of going out and getting a blood meal. It's only female mosquitoes that bite. They need the blood meal to have the protein to be able to lay eggs. And so there's these different sweet spots as you look at this of where the combination of temperature and precipitation is the best, not only for the mosquito survival, but for having disease transmission. So the modeling is a little bit complicated. It's more complicated than for heat. There was a really excellent piece of work done several years ago looking at how much climate change itself is driving change in infectious disease. And these were for actual infectious disease threat events in Europe. So these threat events actually occurred. This is really interesting. This is the kind of analysis that's typically done in genetics. And it was the first time it was applied in health. And it asks the question of how closely related are different variables. What variables are most important and how are they related to other variables? And so someone who's in health, you look at this and the key things that people talk about, our healthcare system, for example, is pretty far down this list. The most important was travel and tourism, number one. Global trade, food and water quality, surveillance and reporting failure, climate, natural environment. It basically says that much of the global environmental change is what's causing these changes, as well as the associated socioeconomic change. The trade and the travel, for example, are so important. Nick Ogden and his group and others in Montreal have been doing decades of work on Lyme disease. And this just shows you for Eastern Ontario the spread of Lyme disease from 2010 to 2016. Do you have Lyme disease here? It's been spreading. It's been interesting because when I first started in the field, everybody said, yeah, we'll never figure out if climate change has anything to do with Lyme disease. It has a very complicated 2-year life cycle. Temperature has different effects during different parts of its life cycle, and it's just going to be too difficult to tease out. And the work that Nick and his group have done have shown that you only need 2 variables to show where Lyme disease is going to move. The first is getting a tick from one place to another, and the birds carry the ticks, so the birds carry the ticks. And the second is temperature. It's just a temperature-driven phenomenon. And using that, then, there's work by the Public Health Agency of Canada on what are we doing about our surveillance systems. To see if you've got ticks, people go out with sheets and drag sheets in forest areas and then look at what kind of ticks you have and can see if there's Lyme disease in them. So there's been quite a bit of work. Most of the leading work has been done either here in Canada or parts of Scandinavia, because they have something quite similar to Lyme disease. They don't call it that. Those are all observations. And I'll move on for a few minutes to projected impact. It's the same kind of list. The list is more compact, and there's far fewer publications. It goes back to really not having any funding. And so 2/3 of the work has been done on heat. There's been some work done on dengue, which I'll talk about, and some work on malaria. The rest of it, there's a smattering of research. But even with that, very high confidence in changes. The summary of all that research is that if we don't do anything in terms of adaptation or mitigation, we're just going to see an increase in the magnitude burden of climate-sensitive health outcomes. For those of you who work in climate, you've seen this before. It just says heat waves have already increased in frequency, intensity, and duration. And as we continue along our climate change track, it's going to become even worse. These show you 1 in 10-year and 1 in 50-year events, show you the increase already. So for the 1 in 50-year events, at 1 degree C, and we're of course almost at 1.2 degrees C above pre-industrial, basically a 5-fold increase in 1 in 50-year heat waves. The heat wave that caused the Pacific heat dome was more than a 1 in 150-year event. From the climatology side, it was particularly interesting because the way that this return period is determined is by looking at the extremes in the climate models and seeing how often these extremes occur. The climate models, when you look at the extreme of the climate model runs, they did not include the event that did occur in the Pacific Northwest. So the climate model said, yeah, that's not going to occur. It actually happened. And so there's a discrepancy between the models and this observation of it could have been a 1 in 1,000-year event. There was a heat wave a few years ago in Japan that the Japanese Meteorological Agency said was impossible. It would never have occurred without climate change. There was a heat wave in Scandinavia, and the Swedish Hydrological and Meteorological Institute said that this heat wave had a return period of 1 in 3 million years. My brain can't really quite conceptualize something once every 3 million years. I'm just going with it was impossible without climate change. These events are so rare, and yet they're happening so frequently. To continue emphasizing this point of adaptation and mitigation, this is modeling from the US of heat-related deaths towards the end of the century. With no adaptation in the top row, with adaptation in the bottom row, The left is high emissions. The right is aggressive reduction, so you've got low emissions. If you compare the map on the top left with the bottom right, those are completely different worlds in terms of how many people can die from the heat. And it shows you the importance of both adaptation and mitigation. The other important point for health, and it's true for other sectors, is if you look at the color, little color chart in the middle, that even with adaptation and with mitigation, there's going to be an increase in heat-related mortality. Residual risks is what we call these kinds of consequences, which means that health systems have to both adapt, mitigate, and prepare for additional heat-related mortality. For vector-borne diseases, again, some data from the U.S. Aedes aegypti is a mosquito that carries dengue fever. The main mosquito in North America is Aedes albopictus in Europe, and I forgot which one it was in Africa. The beige area, this is all modeled. In the U.S., all the vector control is at the state level. So you can imagine there's a little bit of variability across our states in terms of vector control. So modeled based on a lot of work that's been done about the environmental drivers for this mosquito. So the beige area is the present day suitability for having this mosquito present. The red area is projection towards the end of the century. We didn't model up into Canada, but you can see that there's red areas down around Toledo. But it's not just having the mosquito present. You have to have a summer that's hot enough and long enough that you can introduce dengue fever into the mosquito population and have sustained transmission. And so that's what the transmission suitability is about. And you can see an expansion of the geographic range, but nothing like on the left. This paper was published in 2016. A few years after that, breeding colonies of this mosquito were found in Toronto, Toledo, and Detroit. Just like so many areas of climate change, we're under-projecting risk. This mosquito is 100% adapted to human environments. It'll fly a mile to bite a human over anything else. It really does want to. People who are paranoid about mosquitoes, Aedes aegypti is out to get you. It really does want to bite humans over anything else. It breeds in the water in the bottom of a flower pot. It's extremely difficult to eradicate because it's so adapted to our environment. I've never done this, but colleagues have, entomologists have. Apparently, if you go into our sewer systems, there's millions of mosquitoes down there. People think about rats, but actually they're just full of mosquitoes. It's warm, it's moist, there's breeding grounds, and helpfully we often put grates in streets so that they can come and go from the sewer system. Go get their blood meal, go back down and lay their eggs. It's going to be impossible to control this, and it's going to be spreading. It's already spreading its geographic range. And it's a question now of when we're going to see outbreaks in the U.S. of dengue fever, not if. Likely the biggest risk of a changing climate for health is going to be from carbon dioxide itself, in collaboration, in conjunction with the effect of temperature on crop yields. So for those of you who work around the agriculture area, these are projections for middle of the century, end of the century, for 3 different levels of greenhouse gas emissions. I'm going to focus on maize, or corn, rice, and wheat. Soybeans are completely different, so we're not going to think about soybeans. But all we have to do is look at the patterns. Any increase in local temperature is a decline in crop yields. There's about 830 million people in the world who are food insecure. The number is going to be higher next year because of the war in Ukraine. A couple of years ago, the number of food insecure people in the world was closing in to around 600 million. So a big increase in the last few years. And FAO, Food and Agriculture Organization, attributes that to climate change, to war and conflict in vulnerable parts of the world, and to extreme weather and climate events, which is also part of climate change. The second major way that our food security is going to be affected is through higher concentrations of carbon dioxide. All of our plants have a mechanism, photosynthetic pathway, to bring in carbon dioxide from the atmosphere into the plant, to break it apart into carbon and oxygen, and use the carbon to grow. 85% of our plants use one mechanism. The biochemical characteristics of that mechanism mean these are called C3 plants. That's all that C3 means, is just a particular photosynthetic pathway. There's been field experiments, particularly for wheat and rice, which are two critical C3 plants, but also include barley, potatoes, grasses, trees. But particularly for wheat and rice, together they're about 65% of all the calories consumed around the world. And so there's a field of wheat, field of rice, separated into plots, put tubing around some of the plots and grow carbon dioxide over them at 2 times CO2. And based on those experiments, you see here that protein declines 10%, B vitamins decline about 30%, and through a separate mechanism, the micronutrients decline about 5%. You see there's more carbohydrates, and so people are consuming more carbohydrates now than their grandparents did eating the same diet, because there's more carbon in plants. The micronutrient deficiencies is critically important from the health side. I mentioned 830 million people in the world are food insecure. 2 billion have micronutrient deficiencies. About 1.5 billion women and girls have iron deficiency anemia. And so this small change in micronutrients could have a huge impact. I was part of a study that looked at rice, the consequences of the changing nutritional quality of rice in the poorest rice-dependent countries. And the modeling suggests by the end of the century, we're talking about 600 million people could be affected, just in the poorest rice-dependent countries. And this is just from changing concentrations of carbon dioxide. It's an area where a lot more research is needed, and I've been working in this space. It's been fascinating. The number of contacts I have from the media is very, very large about this. The number of contacts I have from potential funders is almost nil. So the media has really picked this up as an issue. I'm hoping that as the people who write checks read the media, that they'll discover that this should be an issue that they fund, because we have to get a handle on this. On the two sides of the impacts and the risks, I want to end, I'm talk about adaptation and mitigation. I wanted to end with this figure, which is an iconic figure in the IPCC. It has been used for over 20 years. It's incredibly familiar to policymakers. They understand this, and so I'm using this now in all my talks to help other people understand. It's a synthetic figure. And I'll start, the baseline is pre-industrial temperatures. The y-axis is increase in temperature above pre-industrial. There's obviously 3 sets of climate-sensitive health outcomes. There's only 6, by the way, for which we had enough data to be able to do this. And this synthesizes the literature. When you look at each of the bars, the white area means we can't tell scientifically if there's been a change, for example, in heat-related mortality. There could have been, we don't have long enough data series, it's not rich enough, we just can't tell. Or maybe there's been no change, we don't know. When the color turns to yellow, it means the risks have changed, and we know that at least part of that risk is because of climate change. When the color turns to red, the risk is high. When it turns to purple, it's very high. We use 3 different adaptation pathways, which I can explain. I think I've been talking a little bit much, and I'm going to try and wrap up in a few more minutes. So I can explain those later if you want, but 3 different adaptation pathways. And those bars are capped at the temperature projection in 2100 from Working Group 1 from the IPCC. The short bars are all for a world in which the world is really, truly aiming for sustainable development. And in that world, temperature, global mean surface temperature doesn't increase above 2 degrees C. And so that's why you've got the tech thing. And so you can look at these and hopefully see immediately, again, the importance of mitigation and adaptation. That we're looking at very different kinds of worlds. Because of the color scheme, nearly everybody who works on these calls these the burning embers. And so you'll see lots of reference to the burning embers. This is what burning embers look like. And as I said, policymakers look at this and it tells them what they need to know. It tells them the risk at 1.5 degrees and at 2 degrees. It tells them if I'm going to spend money for mitigating from 2 degrees down to 1.5, what am I going to gain? And this clearly shows you what you can start gaining, and this is just in health. If you go to the summary for policymakers for working group 2, there's a 2-page spread with nothing but burning embers. Lots of sectors, lots of regions, not enough, but a lot of work was done in the working group 2 report to put these together for a lot of different situations. Is that sort of clear? Good. With that, I want to talk about just 2 more issues. The first is adaptation. There's a lot of work being done, with a lot being in air quotes, on adaptation in health. If you look at the bottom bullets, constraint is limited investment. When you look at all of the adaptation funds under the United Nations Framework Convention on Climate Change, less than half of 1% has gone to health. So there's been a little bit of investment in health. Despite that, there's a long list of adaptation options that are effective. The number one is strengthening the resilience of our health system. The World Health Organization has a framework for promoting climate resilient health systems. This is a graphic that came out recently about this. And so WHO has been working with their member states about trying to increase the resilience of the health systems. The first step is conducting vulnerability and adaptation assessments. And that's the first step for all of the sectors in all countries. Every other year, WHO does a survey of its member states, 196. And the last survey, only 95 countries reported. And of those, only half had done a vulnerability and adaptation assessment. And of those half, only 9 said we even got anywhere near the resources to get started. So significant constraints in the face of a changing climate, knowing that people are being affected, and the ability to actually do something about that. Just one of many examples is surveillance systems, understanding where you've got Lyme disease. The axis, by the way, only goes to 28 countries, so it's a pretty small number of countries, and just shows you for different climate-sensitive outcomes. You probably can't read that; it's pretty fuzzy even here. You just see how small the numbers are. So there's a lot that needs to be done. There's a lot of potential, and working hard to try and get some financial backing to make sure that populations are protected. Mitigation. I assume you've all seen this slide. Yeah, it's depressing. And it doesn't matter what bad things happen in the world, our emissions just keep going up. They went up, it was announced this morning, by 0.8% last year. So it wasn't as big an increase as in prior years, but that was because of the war in Ukraine and because of China shutting down its economy. Unclear what's going to happen next year. I believe that Canada is the same as the U.S. and that the number one source of our emissions is transportation. What gets the attention are all the coal-fired power plants. We do need to shut those down, but less focus is on what comes out of tailpipes. One thing I think has been very unfortunate is that there's been, at least in the U.S., very little publicity about the fact that all major auto manufacturers have given a date when they're out of internal combustion engines. In the United States, in 2030, half of all new cars are going to be electric vehicles. In 2035, they're all going to be. So there's a huge shift going on in terms of transportation, which I think needs to be celebrated much more than it is, because it's going to make a big difference in our emissions. And I'm doing this all as a lead-up because when we think about the major categories of mitigation, and this lists major categories of mitigation, all of them have benefits for health. And the benefits are significant. When you think about reducing exposure to outdoor air pollution, again, 4 million people die from outdoor air pollution. You can start with we've got thousands and thousands of studies of saying if children are not exposed to that air pollution, it's possible to quantify the number of avoided hospitalizations, the number of avoided premature deaths. Economists like to quantify what that means. And for coal-fired power plants and for all these 8 other areas, when you do this quantification, the health benefits pay for the cost of mitigation. So the health benefits are the same order of magnitude, if not larger, than the cost of mitigation. We should be mitigating for our health. And that's a very different message than my governor standing up and talking about all we're doing to reduce our emissions in the state of Washington and being pushed on what the cost is. And yet he never says, and it's going to do so much to reduce our healthcare costs, it's going to make people healthier, it's going to have longer lives. And that's a message that has been tested with various audiences, and that is a really positive message. Don't just reduce your emissions because it's the right thing to do. Reduce your emissions because it's good for your own health and that of everybody around you. The second major category is around transportation, of getting more people walking and biking. And just a small change in getting people walking or biking has huge reductions in emissions, and it lowers blood pressure, it lowers weight, people are happier, and you see then reductions in cardiovascular disease and diabetes and other chronic diseases. And again, the benefits from that shift, even just shifting a small percentage of trips to a bicycle, has huge benefits for health. The third major category, you're going to hear I give a lot of public talks, is diet. And if people only eat as much red meat as their doctor recommends, say anything other than that, you can get into a lot of trouble, but if you only eat as red meat as your doctor recommends, you lose weight, lower your blood pressure, less cancer, less heart disease, less stroke. Right? And so these are all benefits that really should be front and center when we talk about mitigation. One example is from the Northeast of the U.S., and it was looking just at child health over 5 years from a regional trading scheme in the region. And you can see for these different counties, in some of these counties over 5 years, the child health benefits were over $20 million. These are huge benefits, and they're not getting the public attention. So when you think about all these issues, I want you to think about that. I'm going to put this slide up last when we do the questions, and wanted to end with, when we look at climate change and health, about 85% of all the health risks are in children. In the U.S., you say climate change, people think about polar bears. I'm hoping that you'll think about more about children. And how children, by the way, this is from Mali, when I did a project in Mali. It's in children. Children being affected right now. They'll be more significantly affected in the future if we don't take action. And this is a research agenda in the field. It's huge. Happy to talk about this, but mostly I wanted to thank you for your attention and happy to take questions. And if there's no questions, I'll be shocked because I couldn't have been clear about everything. And there's more cookies if you don't have no sugar. Yeah?
Yes?
Thank you. Very informative and helpful. I'm from the local public health unit here, and just wondering if you have examples of local places doing this well in terms of leading action and initiatives in local ways that have been successful.
It's a great question, and I would encourage you to look at what's going on with Health Canada. Health Canada has been leading the way on many of the issues and is working with local communities. One exciting activity that's going to come out this year is thinking about this future of more and more extreme events. That the person at Health Canada who's in charge of this larger group now under Prime Minister Trudeau is Dr. Peter Barry. And Peter and I and others have a paper on stress testing. Because one of the challenges we're finding in the health sector is that people are faced with, we've got so much else we need to do. The climate is changing. And they do a few things, but their mindsets aren't shifting. So the future's going to be completely different. That people have a mindset that the future's going to look like today. And that's frankly the least likely outcome. We know that there's huge shifts going on, not only in terms of weather patterns, but socioeconomic. You've got lots of migration, as we've got lots of migration. There's lots of factors that are going to affect our future. And stress testing comes from, the military does wargaming, and it comes from that kind of tradition. Peter and I, for the first year of COVID, it was February, the first year of COVID, there was a national adaptation meeting in Canada, and we ran a simple stress test. We had a couple of different examples that his group put together. One of them was some flooding event in Saskatchewan in June 30, some date, right? 2032, I think. I don't remember. Putting the stress test together is a fair amount of work because you have to think about the future, what happens to your socioeconomics, your demographics. So you've got to work through those issues. And then came up with something that would not yet have been experienced. So for the Pacific Northwest, I would have done something like the heat dome, except we now have it. And it's a desk-based activity to bring people together, not to point out you can't manage it. We know that a priori you can't manage it. The real question is, what can you start doing today so you could manage it in the future? To help get that mind shifting to how do we prepare for a future that is going to look different. And as I recall, it was set up within this big national meeting, and we had a room, and then so many people signed up, we had a much bigger room, and everybody showed up, and then they didn't leave the room. They were still working through these different stress tests, and were just captured by the idea that they could think about a very different future, and had a tool in front of them of working this through with all of the relevant entities, the building managers. One of the things I didn't mention in the Pacific Heat Dome is we really have to think very broadly about who needs to be at the table. The city of Portland has a light rail system, and they assumed a fair proportion of people could get to their cooling shelters on the light rail system. And you're smiling so you know what happened. Railway lines are tempered to a particular degree, and it was so much hotter than that degree that they couldn't run the light rail system. It happened in London last summer with the big heat waves in London. Their rails are tempered to 25 degrees Celsius, and it was 40. They couldn't run whatever, what's British Rail called now? Whatever British Rail is called now. So it's having the imagination of all of the different groups that need to be at the table. Peter is funding 12 stress tests around Canada, and those are going to be published fairly soon. And that is going to be the answer to your question of particular communities that have really fought through some of the challenges, maybe only from one particular aspect. From somebody who works in this field, I think that's the most important place to start. It doesn't matter where you start, it means you need to start thinking differently. If you can do it for one thing, you can do it for two things. And so they're being funded to do this stress testing. It's going to come out with some really great examples. The other thing you can look at is a variety of communities, including, I'm going to blank on the name. It's a city that starts with a P, which is in Ontario.
Peterborough?
Huh?
Peterborough?
Wasn't Peterborough. I'll have to look up, but has done a vulnerability and adaptation assessment. And so the Health Canada group has worked with that group with their vulnerability and adaptation assessment. And that was published quite a few years ago, and so there's some local guidance on doing vulnerability and adaptation assessment at the local scale. So there's lots going on here that's really exemplar for the rest of the world.
We did a climate and adaptation assessment in 2014.
Yeah?
Here.
Yeah.
But nobody's around anymore, so
That is a problem. Yeah.
thank you.
You mentioned on the economic, the positive economic effects from mitigation and adaptation and dealing with or preventing the public health problems, and how there was some message testing about how that was quite successful. Could you
Teams is so entertaining. Teams is taking over my screen. The good thing is you're not seeing it. I don't know why it's taking over my screen. It's great. There is a group at Yale University that is known as the Six Americas. And if you search for Six Americas, Yale University, you come up with all kinds of surveys they've done, and they've done some testing of a variety of messages around health. One of the results of that survey that's really fascinating is they survey the U.S. public every year of what they think about climate change. And the results are completely inconsistent with what you get from the media. So the actual survey shows that 3/4 of all Americans know the climate is changing. I like to say the rest of them are all in Congress, but anyway, 3/4 know the climate is changing. 2/3 know it's human caused. 2/3 say yes. And those 2/3 think that something needs to be done. Half of them know that climate change is affecting their health. But then one of the questions is, how often do you talk about climate change? And only 1/3 of the respondents ever talk about climate change. So people are worried about it, they're being affected by it, but in a country where there's so much divisive politics, people are unwilling to talk about it. And there's been a lot of emphasis on how to increase those conversations. Because that's how you build the political will, is having those conversations. And my students, I know we have Thanksgiving on different dates, but they'll say, I'm going home for Thanksgiving. How do I talk to Uncle Joe? And so we have questions. It usually is Uncle Joe. I don't know why, but I don't know if they're just making up an Uncle Joe, but they're asking questions about how do I start some of these conversations. And we spend time in class talking about how to think about starting those conversations. The other part that I didn't say, which I think is incredibly important, is what the public tends to hear is we need a transition. We need a transformation. And transformation sounds like everything is going to shift. It's going to be a very different future, and it's out there. And to help them understand, it's already underway. We're already transforming. We need to accelerate it. We need to celebrate it. I mentioned the auto manufacturers. So the story I tell everybody is I recently went grocery shopping. Big, concrete, underground parking garage. I'm walking back to my car carrying my groceries. And I swore I heard wind chimes. And I'm walking to my car trying to figure out how can I hear wind chimes in all of this cement. I calculated the distance to the exit. I thought about everything that was outside. I couldn't figure out where I could hear wind chimes. It took me a while to figure this out. I was hearing the electric vehicles. There was no internal combustion engine in that garage at that moment. All electric vehicles have to make little noises at low speed, and they all make different little noises at low speed. And my brain heard all of that and went, they're wind chimes. And I stood there thinking, this is the future. People are going to go into underground parking garages. They're not going to be stinky. They're not going to be noisy. It's going to be little wind chiming noises and the sound of tires turning on occasionally. And that's just a very different kind of experience for kids growing up. And that's already happening. And so helping, it's part of starting these conversations of, look how much change is ongoing. I'll tell another story just because it entertains me. I had solar panels put on my house, and I live in an area with a homeowners association. Do they have the same bad reputation here in Kent? Yeah, it's a homeowners association. I didn't need to ask, but I thought I'll do the right thing. Told the homeowners association. It was not against the rules, right? It didn't matter what they were going to say, I was going to do it, but I asked. I live in an area where everybody around me works in tech. I got 3 questions. The first was, let's see if I get these in the right order. The first was, could you see them? I have a roof that literally nobody can see, so it was like, no, but also, have you driven around Seattle? They're like everywhere. Does it matter if you see them? The second was, how much noise do they make? It's like, half of you drive a Tesla. Do you understand how silicone panels, you've got a phone, right? It's like, anyway. And then the third was my favorite, which was, what color are they? And I came really close to telling him fluorescent purple. And then I thought, well, that's kind of rude. And I came even closer to saying, I'm going to quote Henry Ford and say you can have them in any color you want as long as they're black. But then after this, I started thinking more about it, started polling friends and colleagues and stuff. I live in Seattle, the Seahawks are huge. And I said, what if you could get your solar panels in Seahawk blue and green? And everybody went, I'd do it. And I said, what if they cost more? I would do it. Except one person said, no, it's got to be the Sounders. I don't want the Seahawks, I want the Sounders. I was just like, what an opportunity for having people having some fun choices for their roof. And there's just metal frames around these panels, right? It can't be very hard to provide different colors of metal or all these new LED lights that you could actually tell it what color you want it to be. And people could have fun with putting solar panels on their roof. So yeah, the transition's underway and we should celebrate it. Are there any other questions? Yeah.
When you talk about the difficulties of funding these areas, it seems to me that it's similar to the difficulty of funding public health in general. And could you speak to the difficulty in health studies between individual approaches and kind of global or macro, I guess is it, and how this is making what you suggest we would do in order to do more like what you're suggesting?
Well, the answer is we need everything at all scales. So, but it is analytically really challenging in health because in health we're very used to comparing an exposed and a non-exposed group. The standard everybody wants to achieve is a controlled clinical trial. We have people not exposed to a drug, not exposed to some kind of treatment, and people who are. Everybody's exposed to climate change. There's differential exposure, but there's nobody who's not exposed. And so it's been an analytic challenge of thinking about how to create some kinds of comparison groups where you can provide some useful insights. It's also been hard when you look at the climate side. I don't know how far back records go meteorologically in Canada, but you know, got over 100 years of meteorological records. And boy, for most health organizations, you're lucky if you've got 10, 15 years of data in the high-income countries. I worked in a couple of places where they had 2 years of health records in a low-income country. And so you've got to be pretty creative in how you think about the data that are available. You've also got to think about the bias in the data and think about what it is that you can usefully try and address and how you can get around some of these challenges. So just on the analytic side, it's pretty complicated. And it does mean that there's a lot of creativity going into different kinds of study designs. But in the end, when you start thinking about, you've got a local health authority here, you need local data. And that's what drives local action. You need province-wide data, you need national data, you need international data. And finding ways to do this at the multiple scales to inform decision-making. Because in the end, policy, for public health, what we care about is interventions. What we care about is making a difference in the burden of disease. It's not just knowledge for knowledge generation's sake. It's not exploratory science. It's always with the point of people are needlessly suffering and dying, and we really need to prevent that to the extent we can. And so we do ask our questions a little differently. Some of the other sectors do more discovery science than we do. And there's a field that is of growing importance in public health called implementation science. And that specifically focuses on how can we better implement and make sure that we have the research operations that we need so that we can take action, informed action, and make sure that we're making good choices. Yeah.
So as the example about the, you going grocery shopping, going underground and carrying electric vehicle sounds, I know that the
the answer is having more EVs sold. I was, as you can probably imagine, sort of an early adopter. And when my first EV was, and it was not a hybrid car, it was the Chevy Volt, so it had a backup generator. It was 100% electric, but with a backup generator. I can't tell you how many messages I received from General Motors of wanting to buy my car back at a premium, right? They wanted secondhand EVs desperately. And we're in that situation now with many of the manufacturers where people are really looking for the secondhand ones. Because they're constructed to last for like 100,000 miles, there's a lot of work going on in the auto companies of how can we get people to do more turnover so that we can get EVs at a lower price. The second part of that is I listened to something on PBS. So one assumes that there was a fair amount of review of everything they said, because I never checked it out. It's before 2030, there's going to be 75 new EVs on the road. 75 new kinds of EVs on the road. And Chevrolet said that they're going to have one that's going to cost $30,000, which is about the price of an average car. And so there's a lot of effort to try and find ways to get the cost down. Elon Musk just said he's going to come out with a Tesla that's going to be lower cost, but he gave no details, and for some reason nobody wants to believe him. I can't imagine why. It's very much on everybody's mind, and finding ways to really facilitate that transition. And of course, we have to have the transition not in the vehicles, but being able to plug in, and making sure that there's the infrastructure there for plugging in these vehicles. So yes, and I have to say, there's a lot of places that are being pretty clever. Do you remember the whole big scandal with Volkswagen cheating on their emissions? So California got some huge chunk of money from Volkswagen, debated, as California does, and they're using the money they received to put in more charging stations, which has drawn controversy because people said I should get a refund from that. California went, we're going to use it for charging stations, so that we're moving into the future. Mercedes-Benz a month ago announced that they're putting in 5,000 charging stations into the U.S. because they want more people to buy their upcoming, or I don't know, do they have an EV? They have an EV? Yeah, so they're putting in more charging stations. So there's real emphasis on making this transformation work in lots of different dimensions. It's not always going to be smooth, it's not always going to be equitable. And at least people are really thinking about it. It's great. Yep.
Yeah, thank you very much for that. So just adding to questioning the whole transition in EVs, there's a very few people who are taking the idea of promoting EVs, basically looking at the global manufacturing chain where cobalt, which is the main ingredient for these batteries, are sourced from Africa, and then there's a lot of issues in these areas like child labor and then poisoning of water bodies, all within the framework of promoting EVs. So to me, it sounds like a disconnect between sustainability and also creating progress in these places where climate change already has the most impact. So how do we resolve this challenge?
I've got several responses to that. The first is the people manufacturing batteries know, and there's huge innovation going on in battery technology. I was at a meeting a long time ago, and there was two senior professors from an Augusta University on the east coast of the U.S. who had always been interested in batteries, and every year they scrape together like $1,000, $2,000 to have students do a little bit of stuff. Maybe 12 years ago. And the venture capitalists were now throwing millions of dollars at these guys after they'd struggled for 20 or 30 years of just tiny amounts of money. And there's now lots of innovation going on in trying to find alternatives. The second is, this issue comes up a lot with my students, is number one, the problems are real. And I don't want to discount in any way those problems are real. Mitigation is a place where there's a lot of vested interests. And there's vested interests who are bringing these issues to the fore, not particularly because they care about what's going on in Africa, but because it gets people to think maybe I shouldn't get an EV because it's creating problems in communities in Africa. And it's really important to step back and look at the big picture of why is this information being brought forward? Does somebody have a particular issue they want to use to get people to not change their behavior? And so you do have honest actors who are pointing out we have to address the problems we've got right now. And you've got others who are taking advantage of that. And so we're seeing in the right wing in the US lots of coverage of this as an issue, where frankly they just don't want people to buy EVs instead of actually doing something to solve the problem. That makes sense. So yes, it's a real problem. Yes, there are efforts to mitigate it. Yes, those efforts are not going fast enough. And the bigger picture is, how can we protect current workers while we continue this transformation? Because if we don't mitigate climate change, we're condemning ourselves to a very different future that we don't want to have. And finding ways to go through these complex issues. These are very complex issues. And finding ways to help people understand the real problems, the real challenges, and what the opportunities are. Yeah.
I'm just reflecting on your last slide where you said climate change vulnerability, 85% affects mainly children. The United Nations declared 2020-2030 as the decade of aging, where emphasis is on the vulnerability of older people to health impacts and climate change and all that. I'm just wondering, one, is that even a good move? And the second one is, isn't that a little bit of a disconnect given that emphasis should be on children in this context?
It's a practical move by the UN. If you look at the high-income countries and the upper middle-income countries, almost all of them have static or declining populations. China is the most rapidly aging country in the world. I read something, I haven't verified it, but by 2100 there's going to be hundreds of millions of fewer Chinese than there are today. What does that mean for all those cities they built? They don't have a social safety net. It's going to be a really big shift. I think the US and Canada are both continuing to grow, but that's from immigration. But it's slowing down, so we're just barely growing. You look at countries like South Korea, which during the Korean War was frankly a low-income country, maybe close to a middle-income country. Its fertility rate now is the same as Italy. They're just rapidly aging. There's been an emphasis on research, as there should be, on children, and just this recognition of there's a lot of places you've got to look at aging as well, that we're just not looking at what happens as populations age, either for us as individuals, trying to get health care for aging diseases is often really complicated, and pointing out that demographics are changing, and when you look at the demographic structure, I think even Thailand's close to replacement, that so many countries are right at replacement, and they're soon going to be going into aging populations. So yes, we need to do that, and at the same time, we can't give up the research on diseases of children that climate change is exacerbating. Yep.
Yeah, thank you very much for the insightful presentation. It is very clear that climate change is health, but I would like to know in what ways and to what extent can help change climate in the form of altering CO2 emission trajectories. For example, during the COVID-19, some studies indicated that changes in socio-economic environment led to a slight decrease in CO2 emissions.
It's a really good point. I said at the beginning I wasn't really going to talk about healthcare, but when you look at healthcare in the United States, healthcare is 8 or 9% of all of our emissions. Worldwide, healthcare is 5% of all greenhouse gas emissions. We're bigger than many other sources. We're inefficient. We leave lights on all night. Really, very little attention has been paid to hospital admissions, healthcare admissions, and what can be done to reduce those. As you said, completely exacerbated during COVID. The amount of medical waste was huge. And so there is quite a bit of thinking about how to get our healthcare infrastructure both more resilient, but a whole lot more efficient. And finding ways to do that in ways that work within, healthcare's got like the smallest margin, I think it's less than food sales. And so trying to find ways to make that happen is a big area of focus. Right now, the U.S. National Institute of Medicine is looking at climate change and health, and their number one area they're starting with is healthcare, and the emissions from healthcare and how to get those emissions down, because it is obviously awkward to stand up and talk with focal points about how important it is to reduce your emissions when I work in a sector that has greater emissions than many other countries have, and making sure that those actions are being taken to be much more efficient. So yes, it's a whole area where there's work going on, and hopefully we'll have some insights coming out soon.
We got
one more question.
Thank you, Dr. Abby, for your presentation. I'm wondering if you know research on when people's mental health are affected by the climate change triggers, either in ways that precipitated through media or being involved by it. How does that affect their ability to respond to all these communication messages around the climate change? Thank you.
It's a really good question, and there's a very long history in public health that's not being drawn on of how to communicate effectively. It took 20 years of testing to get messages right for tobacco smoke. And there has been not enough attention paid to, the health sector really knows how to do things pretty badly. We've done a lot of that. And we've learned over time on how to do some things better. And I mentioned telling the stories about the health co-benefits. I've had, just this last week, I had several students thank me because they said, I'm paralyzed by all the information I'm seeing about how negative the future could be. And finding ways to acknowledge there's a lot of change going on. And we've got opportunities to manage that change. We can reduce some of the risks that are projected. We can be prepared for the risks that we're not going to be able to reduce. And so I showed you all these projections of people dying in heat. They don't have to die in the heat. We can have heat waves without people dying. We've got to make sure we make changes to our infrastructure, to our early warning systems, to other factors. And so finding ways to show people that it's possible to make change. I know nothing about this region in this regard. In Seattle, every other year, Seattle sits in King County, the administrator for King County gives Green Globe Awards. And these are to 18 to 25 individuals, institutions that are making change. Groups that are cleaning up rivers. Groups that are doing just amazingly positive change towards resilience. And I encourage my students, go look these up. They're all in the newspaper. It's really easy to find. And find something you want to do and volunteer for it. And when you volunteer and start working with a like-minded group of people, you start seeing that, in fact, people can make change. I like to emphasize, I haven't so far, is we need collective action. We also need all of us to take action. The IPCC report on warming 1.5 degrees, one of their main conclusions was every action matters. Everything that we do individually matters. Also, don't forget that certainly in the U.S. we've got instances where one person in the U.S. changed all of our traffic laws. Just one. And that was a mother whose kid died of drunk driving. And all of our laws were changed. It's possible for each and every one of us to start making a really significant difference. But if you succumb to, there's lots of change going on, human beings, we really don't like change very much. I don't like my flights being changed, right? All of us have problems with change. But we don't have to be victim to it. We also can take to start taking action, whether it's with a group of friends, whether it's one of the organized NGOs around here. There's lots of ways of thinking about how you can make a difference. And it's amazing how helpful that can be.
I have to ask my own little question.
Of course you can ask a question.
So what do you tell the students to tell Uncle Joe?
So first of all, you start with where Uncle Joe is.
Mm-hmm.
And I live in a state where we've got a huge amount of agriculture. And so I don't talk to Uncle Joe about climate change. What does Uncle Joe see? Has Uncle Joe seen a change in planting patterns? Is Uncle Joe starting to plant a little bit sooner? Uncle Joe had a problem in the heat wave with whatever it is Uncle Joe is growing. There's lots of ways to start talking about our changing environment without ever saying climate change. Because people are seeing it in their own backyards. If Uncle Joe's a gardener, the U.S. changed all of its gardening zones because of climate change. What plants are you planting now that you couldn't before? What do you miss that you'd like to plant but you can't plant anymore because it's too warm? And so that gets you into climate change without starting out with, oh, climate change, but just acknowledging the shifts in our environment. You do have to be careful, though. I use this as an example. My brother's a fisherman. I would not ask a fisherman about what's happening in terms of the fish they're catching, because, man, do they have strong opinions. The water's warmer, the fish go deeper, it's harder to catch the fish. And at least my brother can be very vocal about that. But yeah, there's lots of ways to start conversations. And it's also fascinating to hear what they have to say. I was in the foothills of the Himalayas. There was a project in Bhutan, and they trained, it's a low-income country, and they trained healthcare workers around climate change. And I started the conversation with, you've been trained around climate change, and tell me a bit about your experiences. And this one, they were all farmers, but trained to do basic triage. And this one farmer just started talking about when he was a kid, there was always snow in the mountains for the fall festival. But there's not snow in the mountains anymore for the fall festival. And he went on and told stories for several minutes. And it was just amazing to hear from him how much change he'd observed in his lifetime. And that wasn't, I knew it was because of climate change, but he was just relating the differences that he had experienced. And it's a way to open up and have a conversation without starting from, gotta agree that climate's changing.
All right, well, thank you very much. I bet we had a